Okay, so far we've considered the derivative of a constant and a function. In our case, power function. Yeah? So we know that the derivative, for example, of fx of this one is 0. Yeah, of any constant number, of any constant, the derivative would be 0. And we also talked about the power function. So x, let's say cube, yeah? So its derivative would be 3x squared. So now the question is how to find the combination of a constant and the power function. Okay, how to find this one? Yeah, so that's our task. Okay, first of all, let's find this one using the definition of a derivative. Yeah? So let's say f, so this is capital F, would be equal to k of f of x. Okay, so and now we're going to find the derivative of capital f of x. It will be, so using the definition of derivatives, it will be limit as h approaches 0. Here you will have k f x plus h minus k f of x divided by h. Yeah? So then you can take the k's out of the brackets. Yeah? So it means that you can take limit as h approaches 0, k f of x plus h minus f of x divided by h. Yeah? So here, as you see, this times, yeah? And now you can take k out of the limit. So it will be k times limit as h approaches 0, f of x plus h minus f of x divided by h. So as you see, this one, it is our f prime x. It is a derivative of a function. So it will be k times. So basically our formula is, if you want to find the constant times function, so this is a constant and you have a function, it will be if you want to find the derivative of this one, so this prime always means derivative. Okay, it will be k derivative of k times derivative of f of x. So basically, if you have a coefficient, some constant number, you never touch it. It will remain the same. Okay. Okay. Now let's move to the practice problems. Yeah? Okay. First, let's solve A. So f prime x would be equal to. So you don't touch f5. Okay. This is a constant. You don't touch it. You only deal with this one. You only deal with this one. Okay, you find the derivative of x to the power of 4. That's it. So it will be 5 times 4, and here you have 3. Yeah? So it will be 20 x to the power of cube. Okay, next one, B. F prime x equal to. So here's the same logic. You don't touch 8. You only deal with this one. So it will be minus 8 times 3 x to the power of 2. It will be minus 24 x to the power of 2. Yeah. And then C. Okay, this one is a bit tricky. X over 5. Okay, now here this one you should first find what is your constant coefficient. Yeah, it is 1 over 5. Yes. Okay, now let's find the derivative. So it will be 1 over 5, you don't touch it, and you just find the derivative of x. That's it. So 1 over 5. So here you have 1 minus 1, yeah? And this would be, here you have 0, 1, so you see the answer is 1 over 5. Okay? And now let's move to the last question, D. Here the same, yeah? Okay, I forgot here the fx here. So the coefficient, the k is, this is 1 over 5 here, and then you have this one, 1 over x cubed. Okay, so to find the derivative of this function, first of all, you don't touch k, you find the derivative 1 over x cubed. So it will be 1 over 5. So since it's in the denominator, if you move to the numerator, it will be x to the power of minus 3, yeah? Minus 3. So this is your, now you have to find derivative. It will be 1 over 5 minus 3 times x minus 3 to the power of minus 3 minus 1. Okay, then you have here minus 3 over 5, and then you have here x to the power of minus 4. So this means you can write this one as minus 3 over 5 x to the power of 4. Okay, this is your answer.